Direct linear variation is a special type of linear model where the y-intercept is 0. In other words, the equation is in the form y equals mx instead of y equals mx plus c. So this plus c part here just equals 0. So this part here, okay, is equal to 0, so we don't show it. And when we graph such a line, so a line in the form y equals mx, where do you think the line's going to pass? It's going to pass through the origin instead of passing through some other y-intercept. The gradient m is replaced with the pronumeral k, and this is called the constant of variation. Okay, so the form is going to change ever so slightly. Still means the same thing, but because we're talking about direct linear variation as a linear model, we don't write y equals mx as the equation of that linear model. We write it in the form y equals kx. So the k and the m are the same thing. They both mean the gradient, but we're talking about something here that relates to a linear model, that relates to particular quantities or variables together. So k is called the constant of variation. Sometimes it's called the constant of proportionality. Okay, and that's a sort of a more complicated term that means the same thing, but both can be used interchangeably. Okay, both of those terms. Now, if one quantity is directly proportional to another quantity, and so you might see these words or this term, okay, directly proportional. If you see that, you know then that the relationship is of the form y equals kx. Okay, so that's very important. That's why I've underlined that. All right, direct linear variation as well. I might underline that as well. Okay. Because that's the technical term that we use to describe a linear model where the y-intercept is 0, where the linear model actually passes through the origin. Let's have a look at some examples of that, some real-world examples. Okay, and we'll actually do some proper examples in another video. So real-world examples of direct linear relationships include wages. That's the first thing that comes to mind. Dollars earned varies directly with time spent working. So if you spend 0 hours working, you're going to get paid $0, all right? Especially even on a casual rate of pay, 0 hours, $0. 1 hour, you get whatever you get paid as per your hourly rate, and so on. So the more time you work, okay, or the more time is spent at work, the greater your wage is going to be. And it's based directly on the amount of time worked. What about fuel consumption? So fuel consumption in a car, for example, varies directly with distance traveled. So the longer you drive for, or the longer the journey, the more fuel is going to get used. So we talk about ideal conditions here. So we could talk about, well, what if there's traffic lights, and what if the speed changes, or what if there's uphills and downhills, and strong wind or anything like that. So we just talk about ideal conditions here. Basically, if whatever the conditions we're under, if you're traveling further, more kilometers traveled, it's going to use more fuel. Your car's going to use more fuel. So generally speaking, it's a direct linear relationship. So if you don't travel any distance at all, car's off. It's not consuming or using any fuel. What about the download time of a file? Okay, so the bigger the file, okay, so the bigger the file size, what's going to happen in terms of the download time? What's the effect on the download time? Well, obviously the bigger the download time as well. Okay, again, under ideal conditions, assuming a stable connection speed, and it's not varying, the connection speed itself stays the same, then obviously the larger the file, the longer it's going to take. So a file of 0 size is going to take 0 seconds to download. And so depending on your connection speed, if the file size is doubled, what happens to the download, the download time? It doubles the download time. So for every, say, doubling of the size of the file, it's going to double the time it takes to download. Okay, so in the next video, we'll have a look at an example or two and to see how this works in practice.